correct. Okay, so I wanna pause here because this is the next big topic we're gonna go into. So we're gonna talk about something that's called logistic growth and exponential growth. Maybe you took calculus, you already know what this is, but I'm gonna give you a few examples of that. So this is a rotifer. It's a tiny animal. It's not protista. It's an animal. It's considered an animal. It has a digestive system, mouth, and anus. So it's rotifers. They can be found in pond water. So this model is made using the rotifer population. So you can stick them into test tube, and maybe you put 100 in a test tube, and then you can count them, and then after you put 100 in, you can start counting the new individuals after reproduction. So here's an experiment that someone did. You have rotifer population day 1, and that's 100. And end of the day, you have 122. So you can tell that's how many are reproducing. So I'm not going to go over the whole chart, just maybe the highlighted parts. At day 5, you have 271. 15, you have 1981. And then at day 20, you have almost 5,000 here total with the reproduction. So what this tells you, it's going to give you this J-shaped curve. It tells you that the rotifer population is growing exponentially. It's just growing and growing and growing. So you put 100 rotifers in an environment with abundant resources, means there's lots of space. There are no predators, and there's lots of food. That means the population is going to grow exponentially. If they have food, there's no reason they should crash. They have space to live, they can keep reproducing. So that's going to give you a J-shaped curve here. That's called J-shaped curve. So we can write that down. I'll write that. And that's showing exponential growth. Okay, and then, so this is still showing the same one J-shaped curve. Actually, I wrote that here. So it's showing J-shaped curve. It's growing because there's nothing that's lacking. They have space, they have nutrients. But this is not reality for all the populations. So it's not reality because eventually we're gonna, population runs out of space. Maybe they have competition for resources because there are not enough resources. So it's not reality. But we do this curve still because some organisms show this curve, but because they're not very long lived, they can, still follow this curve. They can fall into this curve. Maybe some of the insects, they grow exponentially, but then, so some of the insects, they can grow exponentially, maybe then winter comes and they mostly die. So they can follow this curve because they have space and nutrients, but then they're not very long lived. Second type we have is called logistic growth. So this is still going over the chart showing how many new individuals are added. And then it's again going to give you this curve, and the growth rate is increasing over time interval. So more days there are, more of them can reproduce, and it's going to grow exponentially. But this cannot, but the exponential growth is not reality. So this is what I was saying. It cannot continue to grow indefinitely for all the populations. That's not true. Maybe some of the short-lived ones. So what's really happening is this growth. It's logistic growth. So when the resources become limited, when any factor increases death rate or reduces birth rate, the population growth levels off. So it gives you this curve. This is S-shaped curve. So it's ramping up here. We have the same rotifer population, but now we add another factor that's called carrying capacity. Maybe we put them in a small space, or we don't give them enough food, or we add a predator. So you can add another factor here. So what you're going to notice is that it's ramping up here. It's ramping up, and then it starts to level off. So it's growing like exponential growth up to here. But then this dotted line is showing carrying capacity, which can be maybe limited food, predators. It can be any of those things, or space, limited space. So that's what this is showing. And that's where it levels off. So if you have maybe 10 donuts and you give that to 100 people, so the population is going to crash because that's not enough for 100 people. So maximum in number of individuals that can survive in the that environment can sustain is carrying capacity. So that's how you would define it. I think I wrote it. So maximum number of individuals the environment can sustain or support is the carrying capacity here. So once you reach that, then the population is going to crash, either because there's not lots of food available or there's not space, then it's gonna kind of level off. So that's the logistic growth curve. And this is called S-shaped curve. I don't know if I wrote that. Actually, yeah, I did. So some populations follow a logistic or S-shaped growth model. As the population size approaches the carrying capacity, the growth rate slows down, just slows down here. So the previous example, the Rutherford population began with 100 individuals and it was ramping up, going up, and that was exponential growth. But then around here, around this time, it almost reached carrying capacity. And once it reaches the carrying capacity or near the carrying capacity, the growth rate slows down because maybe the environment cannot support any more individuals. There's not enough food, you can't keep up. So once it reaches the carrying capacity, it's going to level off like this. So what do you guys think about human growth rate, human population growth rate? Another thing is if you, I'll come back to that question, I just remembered something. So if you took calculus, they probably talked about the slope. So this is a slope. As the slope gets steeper, the faster growth, the growth rate gets faster. If it's flatter or shallow, the growth rate is slower. So if you didn't take calculus, maybe you don't know what I'm talking about, but that's what it's called. It's called a slope. So this is what it's going to look like for long-lived organisms. So going back to my question, what do you guys think about human population growth rate? You think we are following exponential growth curve or logistic growth curve?
Wouldn't we be kind of a little bit of both?
A bit of both.
We exponentially grow because like we've grown a lot in the last few years,
I'd
but we
say-
also are stable in certain locations.
Let's say logistic.
Logistic, okay. Maybe want to see that kind of maybe goes back a lot. So I was trying to look for one that goes back maybe to 1000 BC or something, but I can't find one. So we could just look at this one maybe. Okay, so you see that this is human population, and it starts here and kind of goes up to 2017. So it's not up to date. It doesn't bring us where we are today. Anyways, so now look at this. So Chris said that it's a little bit of both. It's exponential and then logistic. So if you follow this, there weren't that many, there wasn't that much of population, and then something happened, maybe agriculture, and it started growing exponentially, and maybe more modern technology, medicine, and it started growing and growing. So this is exponential growth. Do you guys see it slowing down?
No, because like with new medicine and everything, we're just going to keep on living longer and longer. Hopefully, I mean, with the way medicine's going.
Yeah, so you don't see it slowing down, but then Chris also said that it might be following logistic growth in some places. When he said some places, that means locally. So countries like Italy and Japan, they're not having kids anymore. And that's the places that might be following the logistic growth curve, we're starting to level off. But as species, as human species, we're growing exponentially. And you would think that we would follow the logistic growth curve because we are long-lived. But that's not true. Our population's been following exponential growth curve, and I don't know how long we can keep it up. And some people wonder where the carrying capacity is for human population, if we already passed it, or if we are going to pass it, and if we are going to pass it, how long it's going to take. And that's when we start looking into things like space and food. And another thing is big part in this is science. So anytime there's a roadblock, science kind of finds a way to come over that. So that's for human population. So people have been struggling with the carrying capacity for human population since 70s. They come up with a number, and then our population passes that number. They come up with a new number, our population passes the new number. So they've been kind of struggling with the carrying capacity for human species for a long time now. So I don't know if it's possible to calculate the carrying capacity for human population. So if there was a plague, maybe science came over that. Now we had coronavirus, they made a vaccine. Maybe it did impact the populations some, maybe a little bit, but not enough to maybe slow it down. So this chart is showing exponential growth. Maybe if it was a little bit more updated to this year or next year, then you might see a little bit of slowdown in places like Italy and Japan. So that's locally. But yeah, you would think that human population follows logistic growth, but it follows exponential growth. Maybe locally it can follow logistic growth, but as human species, we're not slowing down. Now we're going to talk about what causes some organisms to slow down. I don't know if you guys heard about the cases of coronavirus in India, but it's killing a lot of people daily. So I don't know if that's going to impact the population size.
Isn't India considered already overpopulated though? Like, I mean, they're one of the highest populated countries. So wouldn't that kind of just still stay?
It might make it
even?
more stable. Yeah. So I'll show you a curve. We talked about the curve of population in India. So it might make it a little bit more stable.
Could the coronavirus be a leveling, population leveling, environmental thing?
Environmental, yes. It's called the density independent factor, and that's what we're going to talk about next.
Okay.
Chris said that currently exponential, but would tend to logistic as resources become limiting. Yes, that's true. And people like Elon Musk, they're looking into other planets for space, and then maybe other resources. So because they might think that the human population is going to reach carrying capacity.